Hello. Welcome back to another episode of Teaching Squirrel Piecewise Functions. Squirrel has decided for most of today that she does not like math. And she woke up this morning and she's like, "No, I'm done. I don't want to do this." So she may or may not grace us with her presence. Um, Yesterday was very fun. We watched some documentaries about the Titanic. Squirrel was very scared. She does not like boats or water. She's not into that. She would prefer to not deal with that. I told her that she should do either math or the Titanic, and she decided nap time, which makes sense. Okay, so let's take a look at this piecewise function homework, and I want to talk to you about this first guy right here. So we are going from -5 to 2 and then 2 to 5, and we are doing x plus 1 and x minus 1. Now, you could do the charts, or I'm going to show you a shortcut on your calculator, because I am. So what you do, go to your calculator, add a graph. This is a beautiful graph right here. Don't have to do a relationship. You could just keep it like this. Go to where you have the absolute value button. Who remembers where the absolute value button is? It should be right next to the book. And if you take a look at the absolute value button, not too far away from the absolute value button, in fact, before you get to the absolute value button, you've got this guy right up here. This guy, piecewise function. Click it. Click it and you get this. At which point you then need to fill in the information. So it's x plus 1 in this box. And then in this box we have from -5 less than or equal to. So control equals less than or equal to x, control equals less than or equal to 2. And then in this one, we've got x minus 1. And in this box, we've got 2 less than x less than or equal to 5. Enter. And there we go. That's exactly what you should get. If I were to do this by hand, it would look -5, -4, -3, -2, -1, 0, 1, 2. And we're just adding 1 to each one. So -5 plus 1 would be -4, -3, -2, -1, 0, 1, 2, 3. And if we take a look, that should be this long line right here from -5 all the way until 2. So from -5, -4 is down here, and then we go up like this, and sure enough, we get a line that looks exactly like that. And then the next piece of it, got our XY chart, is going to go from 2 to 5. So 2, 3, 4, 5. And we're going to subtract 1 from each of the x's. So 2 minus 1 equals, not 3, try again, 1. And 3 minus 1 is 2, 3, and 4. So 2, 1, 3, 2, and it goes up like that. Which, hey, looks a whole lot like this. Now, if you notice, even though we were very, very careful about putting the less than or equal to or less than signs in there, it doesn't tell you the endpoints. So the graphing calculator will do all the graphing for you, but will not tell you the endpoints. So be very careful with those endpoints. So here we've got closed and closed, closed and closed. Here we've got open and closed. And that's how we do that one. So let's take a quick look at the others. All right, so it's a little blurry, but this is what we should get. Notice for the first one, this one is the only open bubble right here. For this one, we've got 3 open bubbles. So make sure that you've got an open bubble here, here, and here. This guy's the only closed bubble, and it should look just like that. Notice a nice platform at level 2 for 1 through 3, and we've got a slanted tipsy platform from -3 to 1. Let's take a look at the back. On the back, you should have a whole bunch of arrows going on here. So the first one I did in green right here for when x is less than -4. So it's less than -4. Here's my -4 going less than -4, and we are sloping like this. And then my middle one is done in blue. Notice we've got closed bubbles on both sides of the blue one, tipsy again. And then for our last one, I did in a pinky purple. We got a nice open bubble there going all the way to the end because x is bigger than 1. Notice for 4, something weird should have happened. In fact, all of our little pieces added together and combined. So for this one, when I started to do the first x and y, I started, okay, 0 and less than 0, so -1, -2, ... And we add 5 to each one, so 5, 4, and 3. That's the 5, the 4, and the 3 right there. Did that, went all the way, keeping that pattern, drew my arrow because it's a ... going towards the arrow. Then we've got a nice platform, level 5, from 0 to 2. That's that straightaway platform. And then the green, you need the x and the y again, and it's bigger than 2. So 2, 3, 4, 5, ... with an arrow. We are doing -2 times our x plus 9. So -2 times the x plus 9 actually gives us 5 right there. So this guy is going to start just where that guy left off. Sometimes that happens. Sometimes it's like nice and seamless. Sometimes you even have a line underneath, so you fill in that bubble. So you've got a blank bubble and then you fill it in. Just depends. Just be careful when you do this. Sometimes they link up like that. If you have questions on the homework, please ask. Let's take a look at what I want to do for today, though. All right. So for today, I want to do advanced piecewise functions. Advanced piecewise functions are similar to what we did yesterday. Very similar. You just have to be careful. So let's take a look at the first one. Yes! Hello, squirrel. You ready to learn? Apparently she just doesn't like homework. What? I told you you need to do your homework. No, it's not negotiable. No, you have to do your homework if you want to pass. I know it does seem unfair, doesn't it? Okay, you can watch the lesson even if you didn't do the homework. Yes, you can. You won't be that lost. I believe in you. I know it looks confusing. If you did the homework, that would help. Silly squirrel. All right. So this is what we are going to be doing for today. If you notice, my first equation right here is not a line. It's not a level, and it's not a linear function. What is a linear function? It's a great question, Squirrel. A linear function has that line in it. It's things that look like y equals mx plus b. So we've got a y equals mx plus b. That's our second one. So negative 2x plus 7, that's going to be a line. Might be a straight line, probably going to be a slanted line because we've got a negative 2 for our slope. So it's probably going to be looking like that at some point because that's what a negative slope does. It's going to be looking like a plane crashing. This guy, however, is not. This guy is a quadratic, also known as a parabola. So we're going to actually see a parabola involved in this guy. So let's take a look at the orange one. We're going to do our XY chart just like we did before. And it says x is less than 2. So 2, 1, 0, negative 1, negative 2, negative 3, dot, dot, dot. And it's going to keep going. Now, the big question is, how many do you need to go? For a line, you only need 2 or 3 points. Once you find the pattern, then you can connect the dots and keep on going. But for a parabola, it's a little bit different. For a parabola, then you have to figure out where's the vertex. Is it a minimum? Is it a maximum? What's happening? So let's take a look at how that actually works. So we're going to do the x squared minus 5. So 2 squared minus 5 is going to get me a negative 1. 1 squared minus 5 is going to get me a negative 4. 0 squared minus 5 is going to get me a negative 5. So far, it's changing and it keeps going down, keeps getting negative. Notice what happens when I do this one. Negative 1 squared minus 5. Be very careful. Negative 1 times negative 1 is a positive 1. So negative 1 squared is a positive 1. Positive 1 minus 5 gets me back to that negative 4. Do you see that symmetry right there? See that beautiful axis of symmetry? It must be hinging at this. This is going to be my vertex. If we take a look at that XY chart, we've got that beautiful symmetric negative 4 on either side. If we take a look at the next one, negative 2 squared minus 5, well, negative 2 squared minus 5, negative 2 times negative 2 is positive 4. So negative 2 squared is positive 4. Minus 5, that's a negative 1. So we've got that beautiful symmetry going on for both sides. So when I take a look at how I'm going to graph this, I'm going to graph 2, negative 1, and then 1, negative 4, and then 0, negative 5, negative 1, negative 4, negative 2, negative 1, and it's going to keep going in that direction. At that point, I know what's happening with the parabola. The parabola is going like that. So that is a big chunk of the graph. It is a parabola. It's not a line, it's a parabola. So we got that guy. Very symmetric on both sides, except notice what is happening at 2. At 2, it stops dead and is just a filled in bubble. Less than 2, if we notice we're going negative 3 and then less than negative 3, we've got that arrow. So make sure that you've got the arrow on the other side. Okay, next one. Next one should be a nice linear function, so we should only need a few points and then we can get it. So x is bigger than 2. So 2, 3, 4, 5, 6. We do not need that many. So it's negative 2x plus 7. So negative 2 times 2 plus 7 is going to be 3. And negative 2 times 3 plus 7 is going to be 1. And negative 2, 4 plus 7 is going to be negative 1. If I start plotting this, I've got 2, 3, and then we're going down. What's my slope? Down 2 over 1. So we're going down 2 over 1. So I know that I just need to go down 2 over 1 for the rest of it. And what do I do for that end point? The end point better be an open circle. Remember, you can't have two closed circles on top of each other like that. That's illegal. So that's what happens with advanced piecewise functions. The advanced piecewise functions, we've got parabolas or quadratics, and we've got linear functions. If we take a look at another one, next one that I want to do is this guy. We're going to do this guy on our calculators. So we're going to see what the calculators look like. Let's do a of x. Scroll got frustrated and ran away. So 2x plus 5 when x is less than negative 3. An absolute value of x plus 1 plus 5. Notice this is an absolute value and an absolute value right there. X is greater than or equal to negative 3. If we take a look at this, what I want you to do when you see any equation, particularly one that we've graphed, I want you to try and start picturing what it's going to look like. For this one, we saw quadratic. Quadratic looks like a parabola, so I automatically knew I was either going to get that, U shape or that N shape, depending on which way it went. With this one, it was y equals mx plus b, so we knew that we were going to get a line somewhere, either up or down. In this case, down because the slope was negative. For this one, right here, this one should look like the zombies. Remember, exponentials look like zombies, so it should be approaching something, and then it should just yeet itself up there. Yes, I did use yeet. That's an exponential graph. And then this guy right here, absolute value graph. Absolute value graphs, we've done a lot of absolute value graphs. Absolute value graphs better look like a nice crisp V. So let's take a look at what happens when we're graphing them. All right, going back to my calculator, gonna hit delete 3 times. Yes, I want to delete everything. Go to tab. Go to my favorite magic button that gives me my piecewise functions. And we've got 2 to the x plus 5. Be very careful. This x plus 5 is all in this exponent. Remember, this will change the exponential function and shift it to the left 5. If it were down on the ground, it would shift it up 5. So it's very, very different whether the plus 5 is in the exponent, or if you hit the arrow button and have the exponent ended and then do the plus 5. And then we've got x is less than negative 3. Let's try again, this time putting x instead of 3. There we go. So much better. Absolute value. Who remembers where that stupid absolute value was? In the Piecewise button. Absolute value of x, and then the plus 1 is inside, and outside is the plus 5. Remember, inside and outside, very different places. It will very much determine which way the V goes. Does it shift up? Does it shift down? Does it shift right? Does it shift left? And it's greater than or equal to negative 3. If we take a look, this is what we should see. You see the little whoop, the swoop here? exponential function, and this is my absolute value function up there. So I want to do menu, view, 6, 3 to get that so that I can copy it down here. If we notice, the exponential function should have shifted this way 5. So that's our first thing right there. Our first point right there is just shifted 5 over, and then go up 1 over 1, and then go up 2, and it should be hugging that right there. Now notice, normally what we would do is we'd hug this, go through the points, and then we just go shooting up. Don't shoot up. Don't do it. If you look, it's less than 3, so this is a tail. It's going to keep going on in this direction. So we've got an arrow on this end. We do not have an arrow on the other end, though. On the other end, for my exponential graph, we have open bubble. Open bubble right there. And then for my next one, this guy, the V has shifted positive 1, which means left 1, and then up 5. So this is where that vertex is. And we got 2 points this way, and then we've got infinite points going this way. Going all the way out. Notice it stops dead here. And for my absolute value graph, we've got filled in bubble right there. So that is how we deal with these functions when we've taken the functions, we've translated the functions, we've moved the functions, we've shifted the functions, we've done things with the functions, maybe even reflected the functions. We're going to chop up the functions and then stitch together with other functions that we've moved and played around with. So this exponential, this zombies versus humans graph that was shifted over 5 units, I shifted it over 5 units to left 5 units and then chopped it off right here at 3. And I took the absolute value, beautiful absolute value graph, shifted it over 1 unit and up 5 units. And then I chopped it off at -3. And I stitched it together just like a beautiful Frankenstein. That's why I call these my Frankenstein graphs, because they're so adorable. They're so ugly, they're adorable. Not as adorable as a squirrel, though. Maybe more adorable than a squirrel. But don't tell squirrel that. She ran away. She can't hear me. She has really good hearing. I'm concerned about that. All right, so for your homework, I just want you to try number 1 and number 2. Number 1 and number 2, we've got absolute value graphs, square root graphs, quadratics, linears, good stuff. So just 1 and 2 for homework tonight. So this is Wednesday, tomorrow is Thursday. If we take a look at our chart, our plan for our life. Where's our plan? Do we have a plan? There's my plan. So today was the scary piecewise functions. Not actually that scary, though. Not scary even a little bit. Tomorrow we are going to review. So I'm going to review and I'm going to tell you how that test is going to work on Friday. On Friday we're going to take a test, but we will be talking about how it's going to go down, what we're going to do, what it's going to look like, what you need to study, all of that for Thursday. Of course, Friday is your test, and because we're not in school, of course, has to be open notes because I can't, come over to your house and steal your notes. That would, well, first of all, it'd be creepy, and second of all, I could get corona, because who knows who has corona out there. I don't have corona. I'm keeping away from the corona. I'm doing very good with my social distancing. Very good. All right. So that is that. Have a wonderful day, and I will see you again tomorrow.